theorems that we talked about yesterday. Remember, we talked about reflexive property. Reflexive property is where they share a side. Vertical angles is where they share a vertice, and then you can add in an angle mark. So we're going to be talking about those as well. So for the proofs, the first thing that you're going to have to do is add in the information that is given. Remember, the given goes in the first section. What you're trying to prove always should go in that last section. So notice that triangle BCA is congruent to DCE. That's what we're trying to prove, and it is always going to be that last step. This is the box here you're going to fill out last. The first box is always going to be the reason is going to be given. So we're going to take the statement that is given and we're going to put it in the first box because it's given. So what's given is that BC is congruent to DC and also AC is congruent to BC. So I'm just going to copy this little sentence right in number 1. So segment BC is congruent to, did I give you a paper? Okay. Okay. Yes. So BC is congruent to DC. I'm also going to put AC is congruent to EC. And then now that I have my picture as well, I'm going to take what I know and I'm going to put that information in the picture. So anything I justify here, I can add to my picture. So I was given that BC, segment BC is right here from here to here, is congruent to DC. DC is right here. So I'm going to put 1 side mark because they're segments. So I'm putting a dash through it. AC, I also know A to C is right here. I'm not going to put 1 dash. I'm going to use 2 dashes because I can definitely tell that AC is longer than BC. So I don't want to put 1 dash there because that means that, like, if I knew this was a length of 5, that would also be a length of 5. I can conclude that those are not the same. Okay, so use 2 dashes. And EC is connected or congruent to this. So put 2 dashes over here. Okay, so that's what we know. Number 2 is blank, but I do have the reason, which is nice. The reason is vertical angles theorem. So which 2 angles are congruent because of vertical angles? What could I say? Angle something is congruent to angle something. Does anybody know? Did you say D or B? B. Okay, B. Nope. But I could go from B, not to A. Where's a vertical angle? Where vertical angles are created by crisscrosses? C. So B to C to A is a vertical angle to the other side because vertical angles are created by an intersection. So if I say BCA is congruent to the other side, what would have to be the matching angle to go with this? If I say D first, what would have to be the first letter? D. And then what would be the middle letter? C, C, and then E. So angle BCA is congruent to angle DCE because vertical angles are created by that crisscross. So and then I added my little arc marks. So now I can conclude that triangle BCA is congruent to triangle DCE by which of the 5 theorems that we talked about yesterday and the day before? If I cover up one of these triangles, which of these theorems on this poster would that match with? Side, angle, side. Because the angle is between the 2 sides, it would be SAS, or I could go start down here, SAS. Either way, the angle's in the middle. I can't jump over B and A and this side because there's literally nothing over here. So I'm looking over here. Okay, so now we're going to do number 2. Number 2. Take a second. We're going to fill in the first part, which is given. The given information is going to go in the top section. What I'm trying to prove has to go in this bottom section. So take a second, fill in your information. Given is always going to be the top. What you're trying to prove is always going to be the bottom. Okay, so if I know JK is congruent to LK, and I also know that JM is congruent to LM, what's my reason that I'm going to put? Given. I should always be the first. I'm also going to take this and I'm going to add it to my picture. So this is segment is congruent to a segment. So I'm going to put a dash through those segments. So JK from J to K, we put one line, is congruent to LK, going to put one line. Those are congruent to each other. I also know JM down here, I'm going to put two lines, is congruent to LM. So I'm going to put two lines. So I'm not going to use one line for all of them because once again, this length is definitely longer than this length. I know that these two are congruent. I know these are two are congruent. I don't know they're all congruent to each other. So I have to use different markings. So now that I know my two sides, I have number two, I have reflexive property, and then I have this filled in. You can't fill in the reason just yet. So we have to fill in number two first. The reason though is reflexive property. We talked about this. Reflexive property is from yesterday. Does anybody remember what the reflexive property is kind of trying to tell me? They mirror each other. So they share that common side. So what segment is congruent to the same thing? What side are they sharing? Which one? Nope, not J and L. M to K. So M to K, they're both sharing this side. So I can use the reflexive property to say that I can say MK or KM, it doesn't matter. So I'll say K to M is congruent to K to M. So the reflexive property tells me that they share a side. So K to M is congruent to K to M. So I'm going to add in 3 ticks because the reflexive property, they share that side. So because I know the sides are congruent, how do I know that triangle KJM is congruent to triangle KLM? What theorem could I use if I cover up one of these triangles? What do I got? SSS. I know all the sides are congruent, so it's just going to be SSS. So take a minute, look at number 3, fill in what you can based on the given, based on the proven. There's 2 little things that you could definitely automatically fill in. Okay, so those are the 2 things that you should have been able to fill out so far, at least right off the bat, without having to think too much. So I know this information, I'm going to add it to my picture. It says given, I know angle G is congruent to angle I. So we're adding to the inside, it's an angle. So I'm adding a little arc, I'm adding a little arc because the angles are congruent, not the sides. The sides we use a little line, the angles we use an arc. I also know that FH, this segment bisects, this word keeps coming back randomly, angle GFI. GFI. We talk about bisecting. Does anybody remember what bisecting means? We haven't talked about it in a minute. If I'm bisecting an angle. Splitting it. So it's splitting into 2 equal parts. Yeah, I thought that's what you said. I was like, what? So it's splitting into 2 equal parts. So it's literally cutting it in half. So what that's telling me is that angle GFH and angle IFH are congruent to each other because it's bisecting it. So if it's bisecting it, it's splitting it. So now I'm going to add in an angle mark over here. Once again, I'm not going to put 1, I'm going to put 2 because I don't know this angle and this angle are congruent to each other. I know this side is actually going to be equal to this side, so I'm going to add my 2 little angle marks over here. The reason why is definition of, anybody want to take a wild guess? Not congruency. Angle bisector. That one's a little tricky. They usually don't have you filling this one in, but use context clues. If this is on the EOC, you, if you were doing this by yourself, I would have like a little word bank for you. This is talking about bisecting. It's an angle bisector. You're not going to just be throwing in random words based on what's given. It's going to connect. It should not. It should be like kind of like common sense. Like, let me use something that they are already talking about. So definition of angle bisector, I can say that these two angles are congruent to each other. The next thing I'm talking about is the reflexive property. Reflexive property is where they share a side. So which side do they share? F. What's up? FH, good. So segment FH would be congruent to segment FH. So the same thing, it's congruent to itself. I'm also going to add that into my picture. So I already know it's an angle bisector. I added my marks. I know FH is congruent to FH because reflexive property, they share a side. And now what could I use to say that these two triangles are congruent to each other? If I cover one of them up, if I cover up the bottom one, what 3 things do I have? What of the 5 congruency statements would I use? AAS. So notice the side is not between the angles, angles next to each other, and the side is just next to the angles. So AAS. A lot of people get confused between AAS and ASA because the side's not between them, it's next to them, angle, side. We're going to do one more in the back together. This one is a little bit longer. So a little bit longer because they're going to get a little bit longer. On your EOC, you can only have a max of realistically 2 blanks. So just an FYI, these have a lot of blanks because we're doing them together. But they could max give you 2 blanks. So first thing's my given. Take a second, fill in what you can based on your given and your proven. And why don't you go ahead and add your pieces to the triangles that you know are congruent to each other. Add in your angles. If you know angles are congruent to each other, add what you can to your picture, add what you can to your proof. Okay, did anybody notice something a little bit weird about number 1? Not the picture. About this sentence compared to the given sentence. The last little bit is not there. So if you notice, given, it says angle N and angle Q are right angles. And this says angle N and angle Q are right angles. But then there's another piece. It says NO is congruent to PQ. So what other line could I put given other than just number 1's reasons? 4. 4 says NO is congruent to PQ. When your proof is longer, notice this one's significantly longer than the front. They're splitting up this given into 2 different places. So since this is here and this is here, this matches, I can add in given right here as well. So if you notice ever your proof is a little bit longer, that's because they're just splitting up your given into more pieces. So now I'm going to go through and I'm going to add in what I can to my picture if you haven't already done so. It says N and Q are right angles. So instead of putting an arc, what do you think I should put if I know they're specifically right angles? Square. So I'm going to add in a square because they're specifically right angles. N and Q are right angles, not just angles, right angles. I also know NO is congruent to PQ, so I'm going to add a little dash because they're sides. And this is what I'm trying to prove. You should already have that in here. Okay, so now I'm going to try to fill in what I can. So N and Q are right triangles, or right angles, sorry, because it's given. I have to fill in a little blank. It says triangle ONP and triangle PQO are blank triangles. The reason why is definition of right triangles. So let's use common sense. What do you think is going to go in that little blank? Just think. Not HL. What kinds of triangles do you think they are? Right triangles. Because definition of right triangles, because it's a 90-degree angle, they're right angles, so they have to be right triangles. 3 is using the reflexive property. So what segment is shared between the two triangles? OP, and you could say PO, it doesn't matter, is congruent to OP. And then I'm going to add that to my picture. I'm not going to use 1 dash, I'll use 2 dash because that's clearly longer than the other sides. I know NO is congruent to PQ because that's given already. And then what theorem out of the 5 theorems could I use to say that triangle ONP is congruent to triangle PQO? HL. So the last one would be hypotenuse leg because those are used for right triangles only.